Imagine a quiet night in July 2025, when the universe whispered something extraordinary. High above the rugged peaks of Rio Hurtado, Chile, the ATLAS telescope, a silent sentinel scanning the heavens, caught a fleeting glimmer in the vastness of space. It wasn't just another speck of light, it was 3I/Atlas, the third confirmed interstellar object ever to grace our solar system. This wasn't a routine discovery, it was a cosmic lottery ticket, a visitor from beyond our stellar neighborhood, hurtling through at 58 kilometers per second on a path so peculiar it defied belief. Then, a twist. Whispers of a signal, intercepted by the United States Space Force, sparked a question that sent shivers through the scientific community. Could this be a message from the stars? Or is the universe once again playing a clever trick on our hopes? Buckle up, because the story of 3I/Atlas is a wild ride through science, mystery, and the unrelenting human quest to understand our place in the cosmos. Let's dive into this interstellar puzzle, piece by piece, and explore what it means for us all. On July 1st, 2025, the ATLAS Asteroid Terrestrial Impact Last Alert System telescope, perched under Chile's star-drenched skies, spotted a faint moving point of light at 4.5 astronomical units from the Sun, roughly 670 million kilometers near Jupiter's orbit. This wasn't just another comet or asteroid. This was something rare, something alien, officially named C/2025 N1 Atlas, or 3I/Atlas for its interstellar pedigree. It joined an elite club as only the third object confirmed to originate beyond our solar system, following 1I/Oumuamua in 2017 and 2I/Borisov in 2019. The 3I designation, assigned by the International Astronomical Union's Minor Planet Center, marked it as a true cosmic nomad, unbound by the sun's gravitational embrace. What made 3I/Atlas stand out wasn't just its origin, but its behavior. Early images from the Hubble Space Telescope revealed a fuzzy coma, a glowing cloud of gas and dust stretching up to 15 miles across, born as the sun's heat vaporized its icy core. That core, estimated to be between 0.3 and 5.6 kilometers wide, likely under a kilometer, was a frozen relic from a distant star system. Unlike local comets that loop back to the sun, 3I/Atlas followed a hyperbolic trajectory, a one-way ticket through our solar system, never to return. Its speed, a blistering 58 kilometers per second, and its path, skimming just 5 degrees off the ecliptic plane but moving retrograde, set it apart. This wasn't just a cosmic flyby, it was a statistical anomaly, a visitor that seemed to know exactly where it was going. The discovery wasn't a stroke of luck, it was the result of a global effort. The Atlas team, alongside surveys like the Zwicky Transient Facility, pieced together pre-discovery images tracing 3I/Atlas's journey back to mid-June 2025. Amateur astronomers too played a role, spotting its faint glow as it slipped through crowded starfields near the galactic center. NASA and the Jet Propulsion Laboratory confirmed it. 3I/Atlas was no fragment of our solar system. It was an interstellar traveler, and its arrival was a once-in-a-lifetime event. As observatories worldwide turned their lenses toward it, the question wasn't just what it was, but why it was here. If 3I/Atlas's origin was intriguing, its trajectory was downright baffling. Picture a cosmic pinball machine with planets as bumpers and 3I/Atlas as the ball. Its orbital inclination, a steep 175 degrees, meant it was moving almost perfectly opposite to the planet's orbits, a retrograde path that's rare for any object, let alone one from another star system. Statistically, the odds of an interstellar visitor aligning so closely with our solar system's plane yet moving backward are about 0.2%, a 1 in 500 chance. But that was just the beginning. As 3I/Atlas barreled inward, calculations showed it would pass unusually close to not one, not two, but 3 major planets: Venus, Mars, and Jupiter. In early October 2025, it would skim within 30 million kilometers of Mars, a cosmic hair's breadth. Its brushes with Venus and Jupiter were similarly tight, each encounter timed with uncanny precision. According to researchers at Harvard, including Avi Loeb, the probability of an interstellar object randomly achieving this triple planetary flyby is a staggering 0.005%, 1 in 20,000. To put that in perspective, you're more likely to win a major lottery jackpot than to see a trajectory this precise by chance. The timing added another layer of mystery. 3I/Atlas's perihelion, its closest approach to the sun, occurred on the far side of our star, hidden from Earth's view. This wasn't just inconvenient, it was almost strategic. The sun's glare blocked our best telescopes during the object's most critical phase, leaving astronomers grasping at shadows. Loeb, never one to shy from bold ideas, noted that this path, maximizing planetary encounters while minimizing visibility, would be ideal for a probe designed to observe or even interact with our solar system while staying under the radar. Was this a natural quirk or something more? Then came the bombshell, a signal. The United States Space Force, with its vast network of radar and listening posts, reportedly detected something unusual tied to 3I/Atlas. The space surveillance network, including the Space Fence Array on Kwajalein Atoll, is designed to track everything from satellites to marble-sized debris in low Earth orbit. Its sensitivity is staggering, capable of spotting centimeter-scale objects thousands of kilometers away. The Deep Space Advanced Radar Capability, DARC, now operational in Australia, the UK, and the US, extends that reach to the geosynchronous belt where communication satellites orbit. These systems don't just track objects, they listen for anything out of the ordinary, any blip that doesn't match known patterns. No declassified records confirm a transmission linked to 3I/Atlas as of September 2nd, 2025, but the rumor alone set the scientific world abuzz. Could a signal from an interstellar object be the first hint of extraterrestrial technology? Or was it another false alarm like so many before? To answer that, we need to understand how astronomers hunt for signals in the cosmic noise. The possibility of a signal isn't just a scientific question, it's a deeply human one. It taps into our oldest dreams and fears. Are we alone? And if we're not, what does that mean for us? As the Space Force's radar arrays hummed and astronomers recalibrated their telescopes, the world held its breath, waiting for answers that might redefine our place in the universe. Detecting a signal from deep space is like finding a whisper in a hurricane. Radio telescopes scan the waterhole band, frequencies between 1420 and 1666 megahertz, because it's a quiet zone, free from most cosmic and human interference. It's where scientists, like those at the Search for Extraterrestrial Intelligence, SETI, hope an intentional transmission might hide. But a spike in this band isn't enough. Every candidate signal faces a gauntlet of tests. First, astronomers check for Doppler drift, the shift in frequency as an object moves. Like the changing pitch of a passing siren, a real signal should match the object's motion. The famous WOW signal of 1977 passed this test, showing a drift consistent with a cosmic source, but it never repeated, a critical flaw. Repeatability is key. A true signal should reappear when telescopes revisit the same spot. The on-off test follows, where astronomers alternate between the target and empty sky. If the signal vanishes when the telescope moves away, it's promising. If it persists, it's likely local interference, a satellite, an aircraft, or even a microwave oven. Modern searches lean on machine learning to sift through millions of signals, flagging only those that survive every filter. Even then, most candidates are false positives. The BLC-1 signal of 2020, detected at Australia's Parkes telescope while observing Proxima Centauri, seemed perfect. A narrowband tone at 982.002571 megahertz, persistent for 5 hours, with a drift suggesting a rotating planet. Yet, after months of analysis, it was traced to human interference, overlapping electronic signals mimicking a cosmic source. This is why astronomers like SETI's Sophia Sheikh and Dan Wertheimer approach every signal with skepticism. The process is slow, methodical, and unforgiving. Until a signal passes every test, it's just not. Enter Avi Loeb, the Harvard astronomer who thrives on pushing boundaries. In August 2025, he introduced the Loeb scale, a new way to classify interstellar objects based on how far they deviate from natural expectations. Rated from 0 to 10, a score of 4 marks the threshold where conventional explanations start to wobble. Both 1I/Oumuamua and 3I/Atlas earned this rating, and for good reason. For 3I/Atlas, the anomalies stack up. It's 1 in 20,000 chosen trajectory, threading past 3 planets with surgical precision, its retrograde near-coplanar orbit, its size potentially up to 5.6 kilometers, larger than most comets, and that hidden perihelion shielded by the sun. Loeb argues that this path, maximizing planetary flybys while minimizing detection, mirrors what an engineered probe might do. He's not alone in wondering. The dark forest theory, a grim idea where civilizations hide to avoid hostile attention, suggests such stealth could be deliberate. Simulations by Loeb's team even show that a reverse orbit maneuver at perihelion using the sun's gravity could let a probe settle into orbit or deploy smaller devices toward planets. Most astronomers remain cautious. A level 4 rating isn't proof of technology, it's a call to keep watching. Every new data point, every observation could tip the scales. For now, 3I/Atlas is a puzzle that demands scrutiny, not speculation. What if this isn't just a comet? What if it's a sign we've been waiting for? The story of 3I/Atlas isn't just about orbits and signals, it's about us. It's about the spark of wonder that drives humanity to look up and ask, what else is out there? For centuries, we've gazed at the stars, weaving myths, building telescopes, and sending our own messages into the void. From the ancient Greeks charting constellations to the modern scientists scanning the waterhole band, the search for cosmic connection is woven into our DNA. 3I/Atlas, with its improbable path and whispered signal, feels like a personal invitation from the universe. It's a reminder that every discovery, every anomaly is a chance to expand our understanding, not just of space, but of ourselves. Whether it's a natural oddity or something more, this interstellar visitor has reignited a global conversation, uniting astronomers, dreamers, and skeptics in a shared quest for truth. Behind the mystery of 3I/Atlas lies an arsenal of human ingenuity. The Space Force's space fence and dark systems are marvels of engineering designed to catch the faintest hints of the unexpected. Space Fence, with its radars sweeping the skies from Kwajalein, can detect objects as small as a marble thousands of kilometers away. DARC, with its global network, tracks the crowded geosynchronous belt, ensuring no anomaly goes unnoticed. On the civilian side, telescopes like Atlas and the Zwicky Transient Facility rely on advanced algorithms to sift through star fields, spotting needles in cosmic haystacks. The Hubble Space Telescope, still a workhorse in 2025, provided the first glimpses of 3I/Atlas's coma, while amateur astronomers, armed with backyard telescopes and passion, helped trace its path. This blend of cutting-edge tech and human curiosity turned a faint blip into a global phenomenon, proving that our reach into the cosmos is only as strong as our willingness to work together. The story of 3I/Atlas is just the beginning. New tools are coming online to hunt for interstellar mysteries. The Vera C. Rubin Observatory, set to begin full operations in 2026, will scan the southern sky every few nights with an 8.4-meter mirror and a 3.2 gigapixel camera, the largest ever built for astronomy. It's expected to spot dozens of interstellar objects annually, dwarfing the handful found so far. Meanwhile, the Square Kilometer Array, SKA, spanning South Africa and Australia, will become the world's largest radio telescope. Its sensitivity will map faint signals across cosmic distances, ready to cross-check anomalies flagged by Rubin or Space Force's radar nets. These tools promise a future where interstellar visitors are routine, each one a chance to test our understanding. Will they reveal more objects like 3I/Atlas with trajectories that defy chance? Or will they uncover something even stranger, a signal that survives every test, a message that rewrites our place in the universe? As these observatories come online, the pace of discovery will accelerate, turning the night sky into a canvas of possibilities. Every new object, every signal is a step closer to answering the ultimate question: are we alone? The deeper we dive into the enigma of 3I/Atlas, the more it feels like a cosmic dance between chance and purpose. Its trajectory, with its improbable alignment past Venus, Mars, and Jupiter, challenges the very notion of randomness. Imagine a traveler weaving through a crowded city, dodging obstacles with such precision that every step seems choreographed. That's 3I/Atlas, skimming past planets with a grace that defies the chaotic tumble of most interstellar objects. The 0.1 0.005% probability of this triple flyby isn't just a statistic, it's a cosmic dare urging us to question whether nature alone could orchestrate such a performance. The retrograde orbit, nearly coplanar with our solar system, adds to the intrigue, like a guest arriving at a party but walking backward through the door. And then there's the perihelion, cloaked by the sun's glare, as if 3I/Atlas knew exactly when to slip out of sight. This dance isn't just beautiful, it's unsettling. It's the kind of precision that makes you wonder if the universe is rolling dice or playing chess. As astronomers pore over the data and skeptics clash with dreamers, 3I/Atlas reminds us that the line between the impossible and the inevitable is razor thin. Each new observation pulls us closer to understanding whether this visitor is a fluke of physics or a hint of something designed with intent. Beyond the equations and telescopes, 3I/Atlas holds a mirror to humanity's deepest hopes and fears. For every scientist meticulously analyzing its orbit, there's a dreamer staring at the stars, wondering if this is the moment we've been waiting for, a sign that we're not alone. The possibility of a signal, even unconfirmed, stirs emotions that transcend data. It's the thrill of imagining a message from a civilization light years away, encoded in radio waves, reaching out across the void. But it's also the fear of what such a discovery might mean. Would it unite us in awe or fracture us in uncertainty? The dark forest theory, referenced by Loeb, paints a chilling picture. A universe where civilizations hide in silence, wary of predators lurking in the shadows. 3I/Atlas, with its elusive path and whispered signal, embodies this tension. It's a reminder that our search for answers is as much about confronting our own nature as it is about decoding the cosmos. Every beep on a radio telescope, every anomaly in the data carries the weight of our longing for connection and our dread of the unknown. As we track this interstellar wanderer, we're not just chasing a comet, we're chasing the truth about who we are and what we hope to become. Beyond the equations and telescopes, 3I/Atlas holds a mirror to humanity's deepest hopes and fears. For every scientist meticulously analyzing its orbit, there's a dreamer staring at the stars, wondering if this is the moment we've been waiting for, a sign that we're not alone. The possibility of a signal, even unconfirmed, stirs emotions that transcend data. It's the thrill of imagining a message from a civilization light years away, encoded in radio waves, reaching out across the void. But it's also the fear of what such a discovery might mean. Would it unite us in awe or fracture us in uncertainty? The dark forest theory, referenced by Loeb, paints a chilling picture. A universe where civilizations hide in silence, wary of predators lurking in the shadows. 3I/Atlas, with its elusive path and whispered signal, embodies this tension. It's a reminder that our search for answers is as much about confronting our own nature as it is about decoding the cosmos. Every beep on a radio telescope, every anomaly in the data carries the weight of our longing for connection and our dread of the unknown. As we track this interstellar wanderer, we're not just chasing a comet, we're chasing the truth about who we are and what we hope to become. The saga of 3I/Atlas doesn't exist in isolation. It's part of a lineage of cosmic mysteries that have captivated humanity for decades. Think back to 1I/Oumuamua in 2017, the first interstellar object ever detected, which puzzled scientists with its cigar-shaped form and unusual acceleration, hinting at forces beyond simple outgassing. Then came 2I/Borisov in 2019, a more comet-like visitor, yet still a stranger from another star system. Each of these objects pushed the boundaries of what we thought possible, forcing us to rethink how interstellar travelers behave. 3I/Atlas, with its precise trajectory and rumored signal, feels like the next chapter in this unfolding story. It echoes the excitement of the WOW signal, that fleeting 1977 burst that briefly convinced astronomers they'd found something extraordinary, only to fade into silence. It recalls the painstaking analysis of BLC-1, where hope battled skepticism until human interference was unmasked. These past discoveries are like breadcrumbs, leading us to 3I/Atlas and beyond. They remind us that every anomaly, every unexplained blip builds on the lessons of those before it. The scientific rigor applied to 3I/Atlas, cross-checking orbits, testing signals, modeling probabilities, owes its precision to decades of chasing cosmic ghosts. As we study this latest visitor, we're not just looking at a single object, we're standing on the shoulders of every astronomer who dared to ask, what if? Each new puzzle piece, from Oumuamua to Atlas, brings us closer to a truth that might be just beyond the horizon. The story of 3I/Atlas is a celebration of collective wonder, a reminder that humanity's greatest discoveries are born from shared passion and relentless curiosity. When Atlas first spotted that faint glow, it wasn't just a telescope at work, it was a global network of minds, from professional astronomers to backyard stargazers, all united by a single question: what is it? The data pouring in from Chile, Hawaii, and beyond is analyzed by teams across continents, shared instantly through digital networks, and debated in real time on platforms buzzing with excitement as of September 2nd, 2025. Amateur astronomers, with their modest scopes, contribute vital observations, while supercomputers crunch orbital models, and Space Force radars sweep the skies for the faintest anomalies. This isn't the work of a lone genius, it's a symphony of effort, where every note matters. 3I/Atlas has become a global phenomenon, sparking conversations in coffee shops, classrooms, and online forums from Sydney to Stockholm. It's a reminder that science isn't just about cold data, it's about the warmth of human connection, the thrill of chasing the unknown together. As we await the next wave of discoveries from observatories like Rubin and SKA, this collective spirit will only grow stronger, turning every new signal, every new orbit into a shared adventure. 3I/Atlas isn't just a comet, it's a beacon, calling us to unite in wonder and keep reaching for the stars. The arrival of 3I/Atlas isn't just a scientific event, it's a philosophical one. It forces us to grapple with questions that have haunted humanity since we first looked skyward. What is our place in the universe? Are we a solitary spark in an endless void, or part of a vast tapestry of life? The object's improbable path, its potential signal, and its level 4 rating on the Loeb scale push us to confront the unknown in ways that are both exhilarating and humbling. If 3I/Atlas is a natural phenomenon, it's a testament to the universe's capacity for surprise, crafting a trajectory so precise it mimics intent. If it's something more, a probe, a relic, a message, it challenges every assumption we hold about our solitude in the cosmos. Philosophers like Carl Sagan once spoke of the pale blue dot, our fragile home adrift in a cosmic ocean. 3I/Atlas makes that ocean feel closer, more tangible, and far more mysterious. It invites us to ponder not just the mechanics of orbits or signals, but the deeper implications of discovery. What would it mean to find evidence of another intelligence? How would it reshape our societies, our beliefs, our dreams? Even without answers, 3I/Atlas stirs the soul, reminding us that the pursuit of knowledge is as much about embracing uncertainty as it is about finding certainty. It's a call to stay curious, to keep questioning, and to hold space for the possibility that the universe has stories we're only beginning to hear.